So in a different video are 3, 9, and 13. So number 4. Let's see. Did you have a thought for what U should be?
I was like, why is the DT on top? What do I do with that?
Well, the DT is on top because it's if it works better to see it out to the side like that. That's the same thing.
Okay.
Did you have a guess for what U should be?
2t plus 1.
2t plus 1. Because there's not really much else it could be. If you made it the square root of 2t plus 1, then du would be too complicated to deal with. So du is 2 dt. So I want a 2 in there and a 1/2 out front. So 1/2 integral. I'm not writing 0 to 4 yet because I'm in the process of switching from t's to u's. The 0 and the 4 are t issues, t values. I want them to be u values. So 2 dt is du. Square root of u in the bottom is u to the negative 1/2. Right? Because I don't want to take antiderivatives of denominators or of roots or radicals because that's going to be a problem. So instead, write it as an exponent and then I can do the power rule. But I don't even want to do that yet. I want to switch my t values to u values. Right, because initially these are t values equals t, and I want to switch them to u values. So if t is 4, 2 times 4 plus 1 is 9. So my top limit is 9. And u of 0, 2 times 0 plus 1 would be 1. So my bottom limit is 1. So now everything is in terms of u. The whole problem is in terms of u, which in some ways means I could ignore all of the t stuff. I can work this as a u problem from here on out, never have to go back to t's. Let's see, increase the power by 1. Divide by the new power, so dividing by 1/2 is multiplying by 2. That's kind of convenient because the 2's and the 1/2 will go away. And then I'll evaluate from u equals 1, some people take the time to write that out, to u equals 9. I mean, you don't have to put the u equals because it better be in u because that's the problem. You've switched it all to u's. But that kind of reminds you that these better be u values, not t values. So 9 to the 1/2 minus 1 to the 1/2. I guess that would be a safe stop. It feels like, man, you're almost there. But that is a safe stop. So 3 minus 1, which is 2. But nothing wrong with a safe stop. Questions on that one or another one you would like to see? Number 7. Did you have a guess for what u should be or a thought? No. Just no. Let's see. I want to pick it so that du shows up. Oh, and this was maybe tricky because if u is sine, then du is cosine. And if u is cosine, du is negative sine, but we can handle the negatives. So the question is the cube business. I don't want to have a du cubed. I don't know what that means, how to handle that. So I need to stay away from cubing a du. So I think I want u to be cosine because I'd much rather have a u cubed, I can handle that, than a du cubed. Whoops, not cosine of u, cosine of x. So du would be negative sine of x. Yeah, derivative of cosine is negative sine. So I need a negative on that sine. So small price to pay. So the integral from, I'm not going to put 0 to pi over 2 because I'm in the process of changing from x to u's. So I'm just going to leave it blank for now. u cubed du. That's it. That's a pretty easy antiderivative as far as antiderivatives go. Increase the power by 1, divide by the new power. But that's getting ahead of myself. I want to do the limits. So if x is pi over 2, cosine of pi over 2, pi over 2 straight up, cosine would be 0 there. So the top limit is 0. U of 0, oops, keep my colors consistent here, would be cosine of 0. That's over here. Cosine of 0 is 1. So the integral from 1 to 0 of u cubed. Some of you are just going to roll with that, and who cares? It's always the top number minus the bottom number, and just go with it. Others of you are going to switch them because it feels backwards. If you want to switch them, what price do you have to pay in order to switch them?
Negative.
Make it negative or change the sign. So up to you. Again, completely, it works out the same. Your answers will be maybe in a different order when you get to the end, but it'll still be the same answer. I'm going to switch them and change the sign, but you don't have to. I just prefer to go from smaller to bigger. And AP tests they know how to write questions really well to force you into doing things that sometimes you cheat your way around. So we'll do it that way. So u to the 4th over 4 from 0 to 1. Again, these are u values, so I'm good now. I can evaluate this. 1/4, 1 to the 4th minus 0 to the 4th. Which is a safe stop. There's nothing wrong with that. But that would just be 1/4. If you didn't switch them around, you'd have the negative out front, and you'd have 0 minus 1, so you'd still end up at 1/4. It would just look a little bit different through the course of the problem. All right, 11, 12, or 13, do you want to do one of those? Yes. I did 13 on the other class, so let's do 11 or 12. Preference between those two? 12 it is. 11 just uses the fact that it's even, so you end up doubling something somewhere to get from -3 to 3. Let's do 12. Uh-oh, that might be another even situation since we don't have any 0, we don't have anything past 0 on our given information. All right, usually we'll let u be the inside stuff. So that's usually the case. Even when it's not written as f of something, usually u has been the inside stuff. So du is 1/3 dx. So I need a 1/3 on the dx to make du, which means I need a 3 out front. So 3 integral. I'm not going to put -3 to 3 on there because those are x values and I'm in the process of switching to u values. F of u du. But I need to switch my switch my x values into u values. So if x is 3, 1/3 of 3 is 1. And if x is -3, 1/3 of -3 is -1. So -1 to 1, except that I don't really have -1 to 1. I have 0 to 1, and I know that it's an even function. So because it's an even function, I can double the integral from 0 to 1. And then don't forget that 3 out there. So they gave us this. 6 times 4 is 24.
Why can't I say that f of u du equals f of x dx?
Because that's a really good question. How do I know that f of u du is the same thing as f of x dx? Because that is just that x is just like a placeholder, right? I could put anything in there. F of my old pink triangle could go in there. Whoops, that I would need to do it with regard to the pink triangle, but that would be 4 as well. So f is the name of the function. What's inside is just the variable that we need to call it something. So f of x versus f of u, it's just a matter of what you're calling the inside variable. What the function is doing is f. That's the same for both. So that's why f of x can substitute that in, even though it says f of u. So it's a good question, and one that we just kind of gloss over sometimes. But the big thing is the f is the same. So it's the same function. The inside thing isn't a number, it's a variable. So it's just, are we going to call the variable x? Are we going to call it u? Well, it doesn't matter what we call it.